Hello, thank you for inviting me to the DDN user group and to talk about the University of Florida AI initiative. This is a big event that happened over the last year, and I'll be happy to share the information about it. So here is a little timeline of what happened. One of the aspects that is sort of interesting is the conversation actually started more than a year ago, and initially we all had to keep it secret. So we had to make many preparations, including a multi-million-dollar power upgrade for our data center needed to be started, the planning process, a long time in advance before we were even allowed to tell anybody that we were going to do this. But then in April of 29, the university community was finally made aware that something was afoot with the Provost's AI initiative. He organized a retreat that had 700 people attending because clearly everybody was very interested in hearing about it, where we started to talk about this new initiative. And the initiative is the vision of the provost and the board of trustees and the president and many other people in the university to try and create what is called an AI university. And the vision is that we will infuse research and education and the curriculum across the entire spectrum of the university. University of Florida is a big university. We have over 50,000 students. We're very comprehensive. We have an agricultural school. We have a medical school. We have offices in every county of every of the 67 counties in the state of Florida, where we help agriculture and do outreach activities. And we have religion, philosophy, liberal arts, big engineering school. And the goal is to try and make sure that every student who graduates from the university with whatever degree they have, they are aware of what AI can do in their discipline and how they can use it. That doesn't mean that all of them will become inventors of AI methodology, but definitely they will be able to use it. Then on May 14, Jensen Huang, the CEO of NVIDIA, announces the new AI technology. On June 25th, we got 2 nodes to try and get familiar with the software and the tools. And then on July 21st, we actually make the big announcement where UF and NVIDIA make their partnership. And we have a donor, Chris Malachowski, who is an alumnus from the University of Florida and is one of the 3 co-founders with Jensen Huang of NVIDIA. And he made this donation where he is donating $25 million to the University of Florida, matched by $25 million from the company, NVIDIA, so for a $50 million supercomputer. And that's what we are now feverishly building, and it will be available in January of 21. So together with this Hypergator AI, the NVIDIA SuperPod, the university was already working on upgrading its own supercomputer called Hypergator. And here is a brief history of the Hypergator. Hypergator 1 was taken into production in 2013. It had 16,000 AMD cores. Hypergator 2 was installed in 2015, added 30,000 cores. And now Hypergator 3.0 will be in January, will add 30,720 AMD cores. Plus, we will have Milan cores coming a little bit later to replace the 16,000 cores. So we will end up with over 69,000 cores by the time the summer comes around in 21. And that will be the front-end system, essentially, to this NVIDIA SuperPod. And we already had invested in standard low-end NVIDIA GPUs, 608 of them. We just got a brand new file system that we call the Blue file system of a 4 petabyte capacity that was brought online a couple of months ago. And the double precision lint pack of this new system is about a petaflop or a little bit more. So then the real crux and sort of core of this whole AI initiative is the driving supercomputer that was the donation of our alumnus. and it is an NVIDIA SuperPod. That means it consists of 140 NVIDIA DGX A100 nodes, and I will talk about what is special about them. If you just do the numbers, it has 17,920 AMD 7742 Rome cores with 8 gigabytes of RAM per core. And then the real interesting core is the 1120 NVIDIA A100 GPUs, codenamed Ampere, that's their name. And then it has an additional 4 petabyte all-flash DDN A3i storage system. And the true power of the system is that you don't have just 1120 Ampere A100 GPUs. You have 250 extra switches, InfiniBand and Ethernet, to make sure that all these things can talk together, and so that eventually, with the proper skill and programming, you can have all these 1120 GPUs work on huge amounts of data that are put in that storage system as a single system, a single problem solved coherently by that system. So it's incredibly powerful, but it's not trivial to get to that super duper power level. And to give you some interest, since it is a part of the supercomputing user group here, the double precision linpack for this system is 13.75 petaflops, 13.75 million times a billion operations per second. Now, these are the double precision benchmark, and that's good for simulation when you want to use double precision numbers. But the AI floating point operations are counted slightly differently. For AI operations, we all know that many of the calculations can be done with single precision and even half precision. Then the performance of this system is a astounding 0.7 exaflop. So it's almost an exaflop machine, 700 petaflops. Here, we're showing some of the activities that are already ongoing. The actual DDN storage system has already arrived. And here you see two engineers rolling it off the crate. The walls of the crate have been removed. And then the second slide on the right-hand side, that's where the rack has already been put in a temporary location. And it's powered up, and it's being configured this week, actually, or last week and this week. And so we're almost ready to go, but it's not in its final location because the data center is undergoing some significant power upgrade, and that'll happen in the second half of the data center. And you can see in the background, there is some plastic separation that to make sure that in the region of the data hall behind that plastic, where workers are doing things, they're welding and making all kinds of dust, make sure that that dust doesn't enter the area of the data center that is in full operation. So how does the system get used, and how powerful is it? So the first level of use for this A100 system is to just use a single GPU. And these new GPUs, the Ampere A100 class GPUs, are really a big upgrade from the Volta. It's really the next generation Volta. There have been some intermediate upgrades that NVIDIA put out in the years in between, but this is a qualitative, really game-changing new architecture, lots of new details, lots of new features, and a lot more power. So you can use the AI tools. Many of them have been refined by NVIDIA and are available to use, and they can be controlled by the normal tools, PyTorch and other tools that everybody who is working in the AI world is already aware of. And of course, it runs CUDA, so you can run your CUDA code on them. So that's the first way of using this system. The second way is, because all the GPUs go together in a DGX node, DGX is architected by NVIDIA and fully specified to hold 8 of these A100 GPUs and make sure that they can all talk to each other at full speed, and essentially allow one GPU to read data that is in the memory of another GPU using the NVLink protocol. So that would be the next level of sophistication. If you have a more demanding AI application or a more demanding simulation or modeling application, then you can program the system so that it uses the NVLink and all 8 GPUs in one DGX node can work together. But like I point out here, there's some assembly required. There are some applications that can do this already, but not all applications will immediately be able to use the full power of a DGX node. And then the next level is that all the nodes are connected by a multi-path, namely 8 InfiniBand cables leave every node to an InfiniBand fabric, HDR fabric. And then you can essentially use this hybrid communication pathway of having the 8 GPUs in one node talk through InfiniBand to all the GPUs in all other nodes. And that may be hard. There are some applications that can do it, but not all applications will immediately make use of that power. And then this data monster can read and write data from the DDN storage system over a separate InfiniBand fabric. So there are 2 separate cables, in addition to the 8 that we already talked about for MPI communication between the nodes. There are 2 cables to a separate set of switches that will connect to the storage system, so that you can also have at full speed the GPUs read the data from the storage and write data back. This AI initiative structure that the University of Florida is creating to make optimal use of this donation, and at the same time advance the goals that the university has set to really make this a pervasive activity across the entire portfolio of education and research. We have the following infrastructure in place. So at the education level is managed by the Office of Provost. There are several work groups across colleges working on courses and certificates. Some of them have already been put in place. Some of them have been starting. Some of them will now be created and advanced even further. In addition, we will leverage the NVIDIA Deep Learning Institute teaching kits. The NVIDIA engineers have developed teaching kits that faculty who are trying to teach AI tools and their use in their courses integrated with their domain topics, they can use these kits to really enhance and make sure that the students fully understand the use of AI in that particular domain. And then for research, of course, is controlled by the Office of Research. There is a research work group with 1 representative from all the 16 colleges at the University of Florida. We are working on a group of experts because we know that there's a lot of faculty who have a notion that, well, their research could be advanced by using some AI, but they don't necessarily have the background on how to use AI correctly or even where to start. So we're creating a group of experts that they can turn to, who will then guide them to the right tools, the right methods, the right education, to make sure that their research project becomes successful. And here also we leverage, as part of our NVIDIA partnership, the Deep Learning Institute. There are hands-on workshops. They're typically a day long, and they focus on a topic and really go in depth with hands-on use. But clearly these hands-on one-day workshops are focused on the use of the tool. They are not a replacement for taking a semester-long course on learning about AI and what AI really is. And then essentially my office, I'm the director for research computing. My office basically manages the training and the technical support, and we manage the system. So how do faculty get started? Well, basically, if a faculty member wants to use the system and AI in their courses, they should contact us. We will set up an allocation for a semester, and then we basically provide the training in the beginning, and we train the TAs so that they can respond to the student problems, and then we will do the back-end support so that it scales, because we cannot provide support for 50,000 students. And then for research use, the thing is organized around investigator investments. They basically buy a number of resources for the use for a year with their grant funds for a year or 2 years or whatever the length of their grant and research is. And then we help them get their work done. And there is also the possibility for a college or a department to buy some resources so that their faculty can get to learn how to do this. And this is how we will support in a scalable way this AI infrastructure, which, as is of interest to this user group, is sort of powered by a DDN storage system. And here I will show you the graphical timeline of how we plan to implement this. You can see that we started early to build, making the plans for the data center, and then there are some delivery dates, and our goal is that in January we can turn on the system for early users, and then some more activities need to do to close it out, and then we will be in full production in the spring semester. And here are a couple of links. The AI University has its big centralized website, ai.ufl.edu, with all the listings for resources and events. And then, of course, the research computing website, rc.ufl.edu. And I'll be happy to answer any questions. Thank you very much.